Hello everybody, thank you for joining today. My name is Minim and today we're going to be looking at the IV, so current voltage graphs of resistors, diodes and lamps. Okay, so something that you really need to know are what voltage, current and resistance mean. If you're not too sure about that, please go back to my older videos and have a look at those. If you are, let's get right into it. Let's start off by having a look at resistors. So resistors are small components which allow you to control both the voltage and current flowing in a circuit. Alright, now a key feature about these is that resistance of these fixed resistors resistor stays constant. Now that is a very key point that you must remember because it's going to come in handy when you have to remember the shape of its IV graph, so current against voltage. But let's so some examples of where resistors are used are in sensing circuits. So I've covered those in later videos. So those include LDR circuits, so light dependent resistors, and thermistors. Okay, so resistors can also be used as switches in sensing circuits, or they can be used as potential dividers. So this just means that they're able to split up potential difference voltage to different components, whatever way you'd like. Now, the resistance of resistors varies depending by the color that's printed on their body. So if I draw a quick picture of like a resistor, so it's kind of like that, and they're usually ceramic, and they have colored bands on them. Okay. The different combinations of colors tells you what sort of resistance that particular resistor has, but that's not something that you need to be able to decode or anything for your GCSE. You just need to understand its circuit symbol, which is just a plain old rectangle like that. Now we want to have a look at its IV graph. So that is its current I, which is measured in amps, plus against voltage V, which is measured in volts. Now for a resistor, current and voltage are directly, actually, you know what, let's do it in a different color. They are directly proportional. That means that it's a straight line through the origin, but it's also straight carrying on through negative territory, because the negative sign doesn't really mean anything but the direction of the voltage, sorry, the current that's flowing, and that's also covered in other videos. So this is what you call the behavior of an ohmic conductor. Okay, straight, let's do it in a different color again. Straight line through the origin. Now you may be wondering, ohmic. Oh, I've heard that one word before. Well, this is to do with Ohm's law, which tells you that at a fixed resistance, as you can tell, these are fixed resistors, so they are voltage and current are directly proportional, and that is shown by a straight line through the origin. So now you understand the uses for resistors and the characteristics for an IV graph. Now you have to be very careful in exams, because sometimes the examples will switch these two axes around, and they'll talk to you about the gradients. Right now, this IV graph, the gradient isn't resistance, because V equals IR, so R is V over I, but this right here is I over V, so the gradient of an IV graph is technically 1 over the resistance. So you need to be very careful if ever you're asked to calculate the gradient, the resistance from a gradient or anything, because you have to have V over I, not I over V. So watch out for that. Now let's have a look at filament lamps. So as always, we're going to draw our simple circuit symbol first, which is just a circle with an X in it. Now, what's the use of a filament lamp? Well, that's to give out light. Now, the filament lamps are very special because at GCSE, because you need to understand their IV graph, which is quite different to all the other ones that we've seen so far. So we have I here, which is amps, and then we have V here, which is volts. Now, the shape of a filament lamp is S-shaped, like this. Now, this shows you that the resistance of the filament lamp changes. Why does it change? Well, that's to do with the temperature of the actual filament inside the bulb itself. Because remember, a filament lamp really just works by passing current through a very thin wire. And as the wire heats up, it glows like orange and white. And that's what gives off the energy and lots of heat. Now, a common mistake people think is, oh yeah, we'll just take the gradient here and we'll find out resistance. No, you don't use gradients, you use single points. You have to read off single points if ever you're given a question where it says, oh, work out the resistance of a filament lamp at X voltage. Okay, you have to use points. Now, let's explain and walk through why resistance of a filament lamp changes. Well, number one, current flows through the filament. Okay. So that's point one. Now, the second point is that charge carriers collide with lattice ions, transferring some energy. Okay, so now what does this point mean? Well, we know that the filament inside the bulb itself is a solid. That means that it has a fixed. Oh wait, hold on. Let's do it in green. All the particles inside the filament are fixed in their positions like this. So let's take it like that. Now, when we have electrons coming through the filament, right? So they're coming through. These electrons sometimes they have to move in between the gaps between the ions, but also they collide into the lattice ions. That's what we have to use of the actual filament itself. Now, when they collide, they transfer some energy. So now, at higher temperature, at higher currents, more energy is transferred to the lattice ions. This means that now think about it, the lattice ions, they have even more energy. Their kinetic energy has increased. So the lattice ions vibrate with a greater amplitude. Right, so this just means that they vibrate even more. Okay, so now think about it. If these lattice ions are vibrating a huge amount, right, they're shaking all over the place. Is it going to be more difficult or less difficult for the electrons to move past them if they're shaking all over the place? Well, the answer is it's more difficult. More difficult for charge carriers to move charge, you know, that's what they do. So therefore, resistance increases. So that's why the resistance of a filament lamp changes with temperature, and why its IV graph ends up having this characteristic right here. Now, although this does look like a lot of different points, if you work through logic, if you apply all the different bits of physics you know to a filament, you can definitely work through this in the exam. I hope you understand that. Now let's have a look at what you could argue is the simplest component of the other two, a diode. So a diode is a component which only allows current to flow in one direction. So what do I mean by that? So if we draw our circuit symbol for a diode here, this diode, you can see that the triangle is pointing one way. This diode will only allow current to flow this direction through it. It will not allow current to flow this direction through it. In fact, if you try and force current to flow through it that way, so if you accidentally connect the diode backwards, it might just melt, right? So let's draw our IV graph for a diode. Up here we have I again. it's in amps, and we have V here, or again, it's in volts. Now, remember how I said that it only allows current to flow in one direction? That means that we get a small bump here and then a very steep climb in voltage and current here. That means that this has a very low resistance in positive direction. So that's the direction that it's meant to be connected in, and it has an extremely high resistance in the other direction, which is why you pretty much get no current flowing at all in this direction. So extremely high resistance in the other direction. So that's how it only allows current to flow in one direction, because current always flows in the path of least resistance. So rather than trying to force its way backwards, which is the extremely high resistance, it will just pass straight through in the direction that the diode is intended to pass it into by the very low resistance. That's what we need to know about diodes.